right, here's your video going over homework 2. So first one, which of the following gives the length of the path described by these parametric equations from 0 to pi? So they're all going to say integral 0 to pi. And you have a great big square root. And then I would just set this up with the blanks, blank squared and blank squared. We're going to do the derivatives of these. So derivative of sine would be cosine of t cubed, and then you have to chain on the derivative of t cubed, which would be 3t squared. All right, and then same thing here, chain rule, we'll have to chain on the derivative of 5t. So 5e to the power 5t. And then we're just going to square those things. So this would be 3 squared is 9, t squared squared would be t to the 4th. And then cosine squared of t cubed plus 25 e to the 10t. Power to a power means you multiply. All right, so let me see which one looks like that. So that is C. All right, this one, same thing. It's going to be integral 0 to 4. So actually right away you can get rid of b because it's got that 2 out front, and e because it has that 2 pi out front. We're not going to have anything in front of the integral. So integral 0 to 4, great big square root, blank squared plus blank squared. Derivative of x would be 2t, and derivative of y, that would just be 1. And then when you square those, this one's going to give you 4t squared, and then 1 squared is just 1. So that would be d. All right, and then this one is asking for the second derivative. So first let's do the first derivative. So derivative of y, that would be cosine t squared, and then chain on the derivative of t squared. And then over derivative of x, that would be 2t, and then the 3 is a constant, so that's gone. So these cancel, and it's just cosine of t squared. And then we're going to do the derivative of that, which would be negative 2t sine of t squared. And then we're going to divide by the derivative of x again, which again is 2t. So those cancel, and it is negative sine t squared. So A for that one. All right, and then the rest of these are going to be review problems because there weren't any other questions on parametrics on there, which is good for us to do review. So function f is defined by this. G is an antiderivative of f. What that means is g prime is f. In other words, this is the derivative. It's the only function that they gave us. That's the one we're going to use. This is your initial condition. Be aware it didn't start at 0. It started at 3. G of 3 equals 5. What is g of 1? So it's going to be where you started, which is 5, and then plus the displacement. It would be from 3 to 1. So 5 plus integral from 3 to 1 of this, and we get to use the calculator because these are all decimals here. So I'm just going to go and type that in. So negative 1.58, they always round. So negative 1.585, and so that one is B. All right, number 5, let f be a continuous function on the interval 0 to 2. The function stays in between 2 and 4. What is the greatest possible value for the integral from 0 to 2? I think this one is kind of interesting. So we're going to integrate from 0 to 2. So from here to here, the function is somewhere in between 2 and 4. Well, if you want to have the greatest possible value, then it's going to have to be at 4. You keep it at 4, that's where you're going to have the greatest possible area under the curve. Again, integral means area under the curve. So if you keep that function constant at 4, integral from 0 to 2 is going to be the area of this rectangle. 2 by 4 would be 8. So D for that one. And then last one, we want the area under the curve for that graph. It's been a while, but we look at these graphs whenever we do limits. You're going to have a flat line at 1 going this way and a flat line at -1 going this way, and then that jump discontinuity at 0. So we want the area from -1 to 2. So that means this And this little box right here and this little box right here are going to cancel each other out. We have a negative area and a positive area. So those are gone, that cancels. And so you just have this little square, which is 1 by 1, which is 1. So B for that one.